Our next topic that we're going to be looking at is optimization. Optimization, as the name suggests, is when we are trying to find an optimum amount of something. So it could be the highest profit, it could be the lowest amount of plastic to use in something, or fencing, etc., etc. So we are either maximizing or minimizing, depending on what they are asking for. And hopefully you will think, as you think, oh, maximizing or minimizing, we know that at a maximum or a minimum, our derivative is 0. So we are basically, for optimization, going to be finding the derivative, setting it to 0, and solving for some x in that case. So let's look at our first example. It's from our book on page 86. A rectangle is formed from a wire that's 60 centimeters long, and its area is calculated. What is the maximum possible area the rectangle can have? Now, in an example like this where we do not have a diagram, the best thing to do is to draw a diagram. So I am just going to draw my rectangle and label the sides. So I'm just going to go X and Y first of all, but I do want both of my sides in terms of one variable. For me, I generally try and do it in terms of X just because I think of things in terms of X, but it doesn't matter. You could have S for the side length. They haven't stipulated anything, so you could do whatever you liked. Now, we do know that the perimeter of my rectangle is 60 centimeters. So have a little think, what would that look like in terms of a sum? You can have a pause and think about that, but I'm going to just carry on going and you can think about it or watch or whatever. So I know that my perimeter is equal to, in this case it'll be 2x plus 2y because it's a rectangle. So I know then that 60 is equal to 2x plus 2y. And I can factorize out the common 2 over there. And then divide both sides by that 2. So 60 divided by 2 is 30 equals x plus y. So y will equal 30 minus x. So equals 30 minus x. I now have my rectangle in terms of x. Now, what are they asking? For the maximum possible area. So I know that my area of a rectangle is the base times the perpendicular height. So in that case, it'll be 30 minus x multiplied by x. Obviously, you could have done that in any order. To find my derivative, I do need to expand this out so that I've got it all just as in its simplest form. So 30x minus x squared. Straight away we can tell it's a parabola and it's going to be looking like that. So I'm looking for the maximum possible area. So what do I need to do to find that? Well, I need to find the derivative. Change in a with respect to the sides x would be 30 minus 2x. And I know that it's a maximum when my derivative or gradient is going to be 0 at the top there. So I'm going to let that be equaling 0. So 2x equals 30 and x will equal 15. Therefore, I have a maximum area when sides are 15 by 15 centimeters squared, because that'll be the total area, which gives me 225 centimeters squared, which you could just check on a calculator for me. So there you go. So don't forget to answer the question. And there you have it. I will show you another example, although to be honest this next one is a bit more difficult, and it's probably not really what you need to be worrying about at the moment, but it's good to have a look. If you can do the really difficult ones, then you're able to do anything. So in this example, small plastic trays with open tops and square bases are being designed. They must have a volume of 108 cubic centimeters. So the internal length of one side of the base is X, and the internal height of the tray is H. So they've given us a diagram in this one. Please use the diagram though. You can scribble on it, do whatever you need to do. Show that the total internal surface area of one tray is given by that. Well, what I would like to have is H in terms of X. Because otherwise I'm going to have a lot of variables in my equation, and we do not know how to differentiate with many variables yet. You will learn later on, but not this year. So let's find out, and anyway in this case you would be able to find out what H is anyway, so you wouldn't worry. So I know that the volume is 108 cubic centimeters. So there is the hint. The hint is that they've given us the volume. So volume of this, it's a square base. So I know that the volume is going to be X squared times H. So the area of the base multiplied by the height. And I know that that equals 108. Okay, so I've just used the information they've given me to solve for the unknown variable that they've given me. So far, nothing too exciting. And I'm wanting H in terms of X, so H is equal to 100 divided by X squared. Sorry, not minus. There's a moment there. We are dividing. Divide both sides by X squared. You're happy with that? To get H in terms of X. Now the first question is to show that the total internal surface area is given by that. So let's use that. So part A is I need to show that. So you can't start with that. We do need to just start with, I know that the surface area is going to be equal to X squared plus 4xh. Just have a look at that and make sure that you're happy. I've got 1, 2, 3, 4 sides. They all have a base of X and a height of H. So I've got 4 lots of XH. Doesn't have a lid, so that's it. So that equals X squared plus 4 x 108 over X squared. And so that solves very nicely to 4 times 108 over X. And I am going to guess that 4 times 108 is 432. 4 8 are 32. Plus 432 as required. That's a Q. Okay, so first of all, they did give us a hint of what we needed to do. We needed to think about getting our H in terms of X. So it wasn't as hard as I thought it was going to be. So find the dimensions of the tray using the least amount of plastic. So that would be my surface area. I'd want a minimum surface area. So it's great that they've actually given us the equation for that. So first of all, so I know that my surface area is equal to X squared plus 432 over X. Now I need to this X X rules and have that at the top there. I hope you remember that from your algebra. If you've got a denominator as an x, it is the same as saying x to the negative 1. That's something you do need to check and make sure you're happy with from your algebra. So I'm now going to find the change in y with respect to my side's x. So this is going to give me 2x minus 432x to the negative 2. You happy with that? The negative just comes to the front and I take 1 away. So I am finding the least amount of plastic. I need to let that equal 0. So I'm just going to rewrite that out. 2x minus 432. I'm here. You happy that that is the same? I'm going to take that to the other side. So I've got 32 over x squared. And now I'm going to easily just multiply up by x squared on both sides, so that I've got all my variables on one side. So I've got 2x cubed equals 432. I can now get my 2 over here to 16. And the cube root of 216. So I probably should have had this up earlier. So 3 shift cube root 216 equals 6. I was kind of thinking that, but it's late. So I know when my height is 6, sorry, when the base is 6, therefore when base is, so when the base is 6, then I know that my height is 108 divided by x squared. And x is 6 in this case, so 6 is a 36. Come on, you can do it. Pen. Anyway, and when you put that into your calculator, you should get 3 centimeters. So 6 by 6 by 3 gives us the optimum volume of our box. So 2 examples. Hopefully that all made sense. I will be around for you to ask questions in our lesson tomorrow.